Hello! Today I'm going to be speaking about trigonometric identities. So these are the sum identities. We sum two arguments in our function sine, which this can be expressed in the form of alpha plus beta or x plus y in our case. This is the whole formula, so sine of x times cosine of y plus cosine of x times sine of y. For cosine it's a bit different. It's cosine of x times cosine of y minus sine of x times sine of y. Based on these two formulas, I'm going to be deriving these two popular identities with you guys. So I can write sine of 2x as x plus x. So I'll rewrite it. And what is this equal to? Well, I'll just look at my formula. So sine of x times cosine of x plus cosine of x times sine of x. Now I want you to look at this and see the pattern. So if we say sine of x is a, and we say cosine of x is b, ab on one side, and we have ba on the other side. We know from algebra that AB equals BA. So what we get is 2AB. So 2 times sine of x times cosine of x. And that's the way to derive this beautiful trigonometric identity. So instead of just memorizing it, you can derive it. Obviously these two you kind of have to memorize. It's really hard to derive them. Cosine of x plus x. On to the next one. So again, we look at our formula. Cosine of x times cosine of, well, you got x again. So that's cosine squared of x minus sine x times sine x. Because we got x here and x here. So that's sine squared of x. Now we can rewrite this formula. We know from the unit circle sine squared of x plus cosine squared of x equals 1. Now what I can do here, I can find out what cosine squared of x is. So cosine squared of x equals 1 minus sine squared of x. So this can be rewritten as follows. 1 minus, well, we've got this expression once and twice, so 2 times sine squared of x. And obviously we can do some other algebraic manipulations and just find out what minus sine squared of x is, which is basically, if we throw our 1 to the other side, it's cosine squared minus 1. So what we would get in the other case would be cosine squared plus cosine squared, which is basically 2 cosine squared of x minus 1. Now, to make this a bit clearer for you guys, what I did essentially is that I found my minus sine squared of x, and I threw this fella onto the other side, so I switched his sign as well, so I got cosine squared of x minus 1 equals minus sine squared of x, and I substituted this into here, so I put this in, I plugged it into here. So what I got was cosine squared of x plus cosine squared of x minus 1, so I got 2 cosine squared of x minus 1. As you can see, two different expressions meaning essentially the same thing. So I urge you to play around with these trigonometric identities. You can post in the comments below what kind of new identities you found or some other patterns. You can derive a lot just based on these two equations, and you'll use them a lot as well. Probably not in high school math, but you'll use these two in high school math, and these two maybe at university. Anyways, I find it very beautiful that we can derive these two equations thanks to these, and that's really the reason I made this video. If you want to learn more about trigonometry, please check out my other videos, and make sure to like, comment, share, and subscribe. See you next time, guys.